So welcome everyone to the first session of the workshop, and I hope you enjoyed the plenary, which I found really very interesting. I welcome you to this session on the Industry Commons Translator. So in fact, it was really great to hear from the plenary speaker about the educational materials and so on that the association is putting together, which really is extremely fitting regarding our objectives as well, to look at the Industry Commons translator role, which obviously requires also education and so on. Housekeeping, the session will be recorded. The recording will be published and available for registered participants. And in terms of the participation, while you cannot speak, please use the Q&A and we will get to your questions during the discussion. And we would like to encourage that. There is then also the possibility via raising hands that you will be invited to the stage and can directly speak with our panel. In terms of the session today, it's about the Industry Commons Translator. This is really the start of a journey to define the profile and role of an ontologist, translator, and kind of coach, to establish best practice, to provide training resources, to make available to industry kind of a directory of who are Industry Commons translators and can help with that task, and to promote that role, ensuring properly ontologized data documentation, and to avoid some of the issues that we have seen in the past. So it is a first step about sharing experiences from different fields. What are the requirements, what are the benefits, and what are the changes that are required to make it happen. And for that, we have some fantastic speakers. We're going to hear from Peter Klein about advancing translation and materials modeling, where the translation has been discussed for some time. Then from Noeske about translation of innovation challenges, and from Nicolas Matentzoglu about the knowledge engineering translation early experiences from the area of the biomedical domain. So all about sharing experiences. Now, as Nadia Adamovich already pointed out, this is a workshop, so we want to elaborate some points, about what are the industry needs regarding translation in order to reap the benefits of ontologies. What can we learn from other fields? And that's what we have speakers here for. What are the existing roles and persons in organizations that are already doing this type of thing? How can the translator contribute to industry adopting ontologies? What are the key steps in their work and their workflows? How can the translator enable changes within an organization? What are the requirements for a role and their training? And of course, the recommended actions. And these are the points, as Nadia Adamovich already pointed out, that will go into the Ontology Commons roadmap, where we also will have a section on this topic, looking at the state of the art, the gaps, the requirements, definition of success, and recommended action. So I will encourage you, and it would be very, very helpful to us if you could, ask questions, make comments, and so on along those lines. So without then further ado, I would like to go back to the speaking roles, and I would like to invite Peter Klein, and just a few words in terms of introduction. He's a senior scientist at the Fraunhofer Institute for Industrial Mathematics, ITWM, in Kaiserslautern, and with many years, more than 20 years of experience in the field and a background in physics. He's covered many areas of the field, ranging from fluid dynamics to medical applications, and he's working on multi-scale models and focuses on surface and interface related phenomena. He is currently the leader of the focus area Impacting Industry of the EMMC and represents Fraunhofer ITWM as an institutional member also on the EMMC, and we'll hear more from him in his presentation. Over to you, Peter.
Gerhard, thank you for the nice introduction. I hope you see my screen now. Okay, thanks.
Yeah.
And I want to thank the organizers of this meeting to give me the opportunity to present my ideas on, on translation, if you like. So let me start a little bit with the history of translation, because this is a global workshop, and I do not expect that all people in the audience know what translation is all about. So all started with an open workshop at Brussels. The EU invited to a policy meeting on modeling, simulation, and design. And in the minutes of this meeting, already more than 7 years ago, we find that there is the need identified to create new actors, namely the translators, which analyze industrial problems and translate them into materials modeling cases. And another need had been identified, namely the development of a modeling community and networking. So from this, the EMMC has evolved, which is now an ASBL. And as you see here from the very beginning, the rule of translators had been an integral part of the beginning of the EMMC, and so it is still now. It's still a hot topic within the EMMC today. In 2019, the EMMC turned into a non-for-profit organization in an ASBL. And there we run a focus area, impact in industry, which combines two strands from the former EMMC efforts, namely the translation as one thing, and business decision support systems on the other hand. And over the years, within the EMMC, there have been developed quite a few milestones. Quite a few milestones have been reached in defining the rule of translation. So the first milestone, obviously, is the paper by Christopher Boyard on translation guide as developed within the EMMC, where 6 translation steps have been identified. So the first 2 are a good understanding of a business case and a good understanding of the industrial case. So this really reflects go to the industry and pick up their interests, their needs, their challenges. The next step is analysis of experimental and probably modeling data, which are already available within industry. And then comes the core step, namely the translation of these challenges into modeling workflows. And the next step, getting to the execution of these workflows. And as a last step, a translator is supposed to help industry to make sense out of the results of simulations. And at this point, the business decision support systems come into the play, because making sense is probably too few. You can even support industry in taking decisions, usually by humans. And the essential idea is that the attributes simulated should be turned into key performance indicators, which make sense on a business level as well. And based on these key performance indicators, support decision-making on the business level, on the true business level. And in the course of combining these 2 strands, translation and business decision support systems, 2 other milestones have been reached over the years, namely a guide on business decision guidelines by Donna Dijkman and co-workers, and a kind of defining overview of translation in materials modeling, progress and process, which really defines or set the stage what is currently the state of the art. And just to mention, we had 2 EU projects as well on business decision support systems, namely Compass Selector and Force. Compass Selector focused more on the point of unifying the project management system using business process model and notation, so an industrial standard, which is already there and which is even ontologized, more focused on the aspect of multi-criteria or multidisciplinary optimization in this arena. Another milestone which has been reached is the MODA, so the modeling data description, which is even a Zen workshop agreement. So on its way to become a standard. And in the end, it is a kind of a tool to document what had been achieved during a translation process. And this brings me in particular to one result from the first project. Namely, if you look at these workflows, then it all starts with a user case input, which combines the business case and the industrial case, if you like. Then you turn it into a model, which is a physics equation and the model relation, which is, after simulation, produces a raw output. And the processed output, in this picture here, is, for instance, a key performance indicator. But what turned out to be in the case in force is that the initialization of the modeling workflow, which translates, in a sense, an industrial question, first into a modeling question, which has to be based on the available data. The solver then answers this question in the modeling space, in the modeling world. But here we need to come up with discretization parameters, discretization methodologies, and both things heavily depend on the initialization data and on the discretization used. And it turned out that an automation in general is pretty hard to achieve in this arena. So we came up with the idea of domain ontologies and their relation to translation. And the question is, what makes a good domain in this case? And this is my personal reflection on that. So ontologies make sense, of course, because they are machine processable. And this means you can digitize things, which is a value of its own. Domain ontologies have to make sense from an industrial application perspective. And there are already industrial ontology standards out there, which we should probably pick up a little bit more. And in the industrial domain, usually a common language exists. So if you produce a new ontology, then it is wise to use the nomenclature of this domain there, while maintaining, of course, logical consistency, in order not to blur the machine processability. Ontology from a materials modeling perspective, and in particular from a user perspective, if the user is the translator, calls for two different things then. Namely, we want to use more than one open simulation platform as translators, which means it is wise to have a top-level ontology, like the elementary multi-perspective materials ontology as developed by this project here in the Commons, in order to support interoperability between open simulation platforms. But within the domain, a domain-specific ontology should provide a correlation, or should handle somehow the correlation between the industrial data lake and the initialization of models, on the one hand, and on the other hand, on the configuration of solvers as well. We have seen that both are crucial for the estimation of the cost of simulation. So if a translator is supposed to estimate the cost in advance, he needs to have all support he can get in order to do that. And from my perspective, a mid-level, or, well, probably not a mid-level, a domain-level ontology should handle that. So this is my first impulse, which I want to give, which comes more or less from an analysis, if you like, of what has already been done. And now I come to a few more impulses coming from a running project, namely WIPCode, which I'm part of. WIPCode is an open innovation platform project, and it picks up the Open Innovation 2.0 policy of the EC, namely that OI2 is a new paradigm based on the quadruple helix model, where government, industry, academia, and civil participants work together to co-create the future. The WIPCode Open Innovation Platform will be designed, I mean, this project is at its infancy, so, but the idea is that the Open Innovation Platform should be equipped with things like collaborative gaming, so serious gaming concepts, with the idea that everyone who participates in an open innovation wins or no one does. And the way to estimate the contribution of each stakeholder here is to use something which is called a Shapley value, or variance of the Shapley value, which is well known in economic sciences. And we want to support, of course, long-term sustainability in innovation and co-creation environments. So the industrial application which we have in mind in order to demonstrate the WIPCode achievements is adapted from active protective coatings. So on the left-hand side, you see here kind of pigments which, through ion exchange mechanisms in water, release corrosion inhibitors. These pigments are part of a coating, and once you have a damage within the coating and water comes in, these corrosion inhibitors leach and form a protective layer on top of the substrate. So this is the short history, the short story behind the demonstrator in WIPCode. And what we see here is already an initial MODA documentation of what has to be done in order to solve these kind of problems with the help of modeling. I will not go through all the details here, but just to mention, what we observed is that probably the workflow as described in the CEN-WA agreement, so this is here on the right-hand side depicted, is probably not enough, because in particular these arrows there are not equipped with a semantic meaning. So this had been the idea of Heinz Preissig, essentially. So how to extend on that? So using the MODA as it is, but just to replace the modeling workflow by a new kind of graphical notation, which is equipped with semantics, namely with interfaces, signals. So signal is an external control, which is not part of the modeling workflow as such, but gives a user, so an industrial person, the opportunity to interact with a simulation and to interact with the system by an external control. So, and this kind of graphical notation, now equipped with a little bit of semantics, can be probably combined with the eMMC translation process. And the basic research question, which we asked ourselves, is: can we devise modeling workflow construction tools like the Promo for translators handling the ontology issues really in their backends, but still generate ontology compliant executable workflows on different open simulation platforms? And the answer is, well, yes, it is possible. If we use rule-based crosswalks from the Osmo, so this is a kind of an ontologized version of the MODA, and the Promo, via an ontology developed by Martin Horsch, which uses knowledge graphs, to the EMMO. And this rule-based system allows for an automation of the ontology-supported materials modeling workflows on compliant OSPs, if the information content, at least in the metadata schema on both ends, are compliant. So this is important. This stresses the importance of metadata schema. If this is not the case, then, well, human supervision of the crosswalk is still necessary. And on the other hand, human supervision may turn out to be advantageous, since one may introduce shortcuts in this knowledge graph transformation system that are hard to detect solely based on rule-based systems. And we've demonstrated that this is really feasible, well, using, of course, the WIPCode example, And this has been published on the FOAMI workshop as part of JOVO. And those of you who attended the last plenary know what I'm talking about here. So this is my second impulse. Automation is possible and should be supported. The next thing is collaborative decision making. In WIP-code, a company, SMT, produces the pigments, another company, AXO, produces the coating formulations, and the next one, Airbus, applies these coatings. So is it possible to advance the, well, first of all, this is a new challenge for Translator, namely cooperative innovation across value chains or across production chains. And this puts new demands, and this is my third impulse on how to evolve on the rule of translators in the future. And the next thing is we have a yes, we have an open innovation platform, and how to advance the rule of a translator onto these open innovation platforms. This is my fourth impulse for the discussions. And with this, I would like to thank for your attention and hope for fruitful discussions. Thank you. Gerhard, I cannot hear you, sorry.
Thank you. Thanks for pointing that out. Yeah, thank you very much, Peter. Yeah, we are a little bit behind time, as usual, but you know, with the intro and everything as well. This was a really fantastic presentation. So many things to talk about. I would also like to encourage questions from the audience. I don't see right now any right there, but I just want to pick up on the MODA, you know, because this is really in itself, you know, I think a tool that has also been mentioned by Ontology Commons that has some similarities with a methodology of ontology conceptualization. Yeah, so this is basically, you know, we need to have high-level concepts and descriptions of things. Do you see a role here for the MODA to advance? And I think basically you already said yes to that, to advance that in terms of well, the two things, you know, one is using this as a basis for the workflow, but the other is also the concepts, you know, to really nail down the concepts that go then in the ontology, because if we don't have the agreement on the concepts, then we can't advance to the next stage.
Yes, sure. So probably what I would like to comment on is, let me see. So this promo thing here is probably important from two aspects. So the first thing is a workflow or a workflow description which is equipped with semantics is, I think, an important ingredient for the next MODA. And the other thing is what Heinz and his co-workers, what they introduce into the picture is a clean separation between what is the core of the model, so a kind of a scoping, if you like. So you have an industrial problem, and of course you need to define the system to be simulated. But there's always the rest of the world, if you like. And what they emphasize on is what is the rule of the rest of the world within a modeling kind of description of the system, namely the use of boundary conditions. The boundary conditions and the external controls. So if you have a process, you always have control. And I think the next level of MODA should include this kind of control as well. So control on processes, I don't know, temperature ramps and so stuff like this.
Okay, thank you. I think it will be probably better if we move on, and then we can have more of a discussion all around across all of the topics. So I would like to thank you again, and then go to the next speaker. Is Dr. Michael Noeske. Oh, yeah. So who is a research associate in the Department of Adhesion and Interface Research at the Fraunhofer Institute for Manufacturing Technology and Advanced Materials, IFAM, in Bremen. Michael is a chemist from Ulm University, as his PhD thesis in the Department of Surface Chemistry and Catalysis. And he's also an European adhesive engineer, which actually plays an important role in this, and I will hear a bit more about that in terms of paving the way of translation at the interface between international partners from industry and research institutions in projects, many different areas of coating and so on. And he's also lectures at the University of Applied Science in Bremerhaven on adhesive bonding technology, etc. So his research ranges from interfactants to formation and long-term behavior of polymer oxide interfaces. And we will hear about translation of innovation challenges in the Ontotrans project from Gerhard. Please go ahead.
Thanks, Gerhard, for the kind introduction. Thanks to the organizers for the opportunity to give this presentation, and I hope you can see the slides. So as Gerhard mentioned, perfect, thanks. As Gerhard mentioned, the topic will be the translation of innovation challenges. And so the target might be shortly formalized as saying, make innovation a white box and fair. That means we work together with human beings, with our customers as translators. So we need to tell them in advance what we are trying to do. And that means the translation gets a white box, and fair means the customer afterwards can find, access, and reuse due to the interoperability that we provide. So we give to the customer the chance that next day he uses a different translator or a second translator in our translator team to continue with the finding a solution to the challenges he's facing. The challenge then is with respect to innovation, and in manufacturing, following the ISO 9000, innovation relates to a new or changed object. New, not only that it did not exist before, but realizing and redistributing value. And these activities resulting in innovation are generally managed. So the partner for the translator at the end of the day is a manager, an innovation manager, and the translator performs a translation together with the innovation manager, a dialogue-based semiotic process. And both of them translate a need into a solution. The need finally comes from different end users, which express human needs, and they are caught by the subtle ears of a manufacturer who then knows, as an organization, there is a chance for us to go to the market, and they want to provide a more and more individual solution to each end user. And so they can now translate the human needs to industry needs expressed to their R&D project managers. And on the way to find specific solutions, a translator may be involved. This translator may be an internal one from the manufacturer's organization, a colleague of the R&D manager, or an external translator, like in the experience of somebody working for Fraunhofer, a huge research institution in Germany. When we contributed to the publication that Peter Klein already introduced, that was published early this year, we said we want to embrace translation in a holistic way. And so the most holistic approach might be to say the high-level innovation challenge is global. That is the challenges we are facing presently and which have as a consequence, for instance, the Green Deal, and the high value to be realized thus also is global. We form ecosystems to gain speed, to join efforts, and to comprise also further generations, which then are also end users of the products which result from the manufacturing process as the outputs. And each individual innovation case that we enter as a translator, and each new product is part of this global scenario. That means we would be able to say from the quality assurance point of view, that's the thought behind, the thinking behind ISO 9000, the quality of a product, which may be a material or a service, is governed by the quality of the information exchange. I must understand my customer, the customer must understand the user of the product, and the user, in the end of the day, is also the one who might later on handle over the product, the manufactured product, to a recycler. And thus the translation becomes a communicative key expertise which facilitates mutual understanding, especially between the manager and the translator. And the more holistic view may be that holistic dialogues are meant to comprise more than two stakeholders. And that means all of the stakeholders around the table, they need to have a common understanding and possibly a common language or system of concepts, as Gerhard and Peter just discussed. And ontologies are fundamental because they have incorporated these concepts and they allow the level comprehensive, holistic, and cooperative translation. And in the Horizon 2020 Ontotrans project, the ontologization or ontologizing is based on EMO, which is strongly developing at present, and this is path-breaking for boosting the translation. If we now have a look at translation, then translation is related typically from our understanding of the word to the communication between humans. That means maybe written or spoken information that is to be translated. And so from the natural language domain, the publication is cited here by Pelkey. They, from a semiotics point of view, have found a systematics that typically the translation and each semiotic process is a sequence of triads by reasoning. First, abductive reasoning, starting from a surprising finding. Then you may take your best shot as a translator. You may say, I think I understand what my customer means. The next step then, which would be also a level from going to the secondness, each of the first persons who express as I, as the grammatical first person, their wishes, their needs in the translation process, then go to a more objective level, and they may do a deductive reasoning, and from that a conclusion is guaranteed. The conclusion may be in materials modeling expressed then in a MODA, and finally an inductive reasoning step is taken, which then afterwards once again leads from the specific to the more general. That means general, we can go back to the wider perspective. That means in the end, from a holistic point of view, we might say the translation process does not end with the answer like 42, but then starts again because new knowledge has been generated by the data 42 and by the way how the data were found that can be reused. So, as Gerhard mentioned, this education as European adhesive engineer then provides a certain way to proceed with translation. There's, I think, several approaches possible, and it's important to communicate the way and then conclude step by step when talking to the manager. So the dialogue partners, they may opt for convention-based semiosis, in this case, the translation. That means following, for instance, the translation in natural languages. There's requirements for translation services formulated in the ISO 17100. in which also the competences required by a translator are formulated. In our domain of adhesive bonding technology, the established procedure, and that's established since 15 years, is a checklist proceeding, which is not so nicely machine readable at the end of the day and can clearly profit from capturing the taxonomies and the concepts and the relations in an ontology. And in the materials modeling domain, the EMMC Translator's Guide is providing the way. The stepwise conclusion for me and for us is important because in the end, we step from one agreement or contract with a customer to the next one, and the conclusion may be recommended after each step of the abductive, deductive, or inductive reasoning, after each triad, or when applying the EMMC Translator's Guide and the 6 steps just presented by Peter, after each of these 6 steps of translation in materials modeling. So then a fair translation and innovation may be facilitated by the Onto translator who uses the ontologization. That means the translators, they perform translation, which is a dialogue-based semiotic process, and there is a second semiotic process, which we call then ontologization. And that means the Onto translator then needs to have certain skills, and at the end of the day, the manager to whom the Onto translator talks also acquires, the more they work together, they cooperate, acquires the skills and gets access to speed up with the developments he needs to initiate for reaching innovation. The innovation during manufacturing in the end means we want to get rid of an old product and introduce something new, and the Onto translator then just when talking to the R&D manager, for instance, uses a mnemonic trick. The German word for this would be building a bridge for a donkey. And this is basically using the ontology. So they agree that whatever they develop, they put as knowledge into an ontology, for instance, the MO. And then at the end of the day, when the solution is presented to the manager, this is not only the word 42, but all of the knowledge behind that has been worked out cooperatively and then belongs to the R&D manager who can use it again. So it's fair knowledge for the manager. The conceptualization that was mentioned also by Gerhard in the discussion with Peter, then would be an option for the 2 partners in the dialogue to agree that they use joint concepts. That means in the manufacturing process, there's some input objects, some output objects, there's objects in the chain of projects which then lead from an input towards a new object, the green one, for instance, and the process chain is then just seen as a sequence of steps. And the specific solution at the end of the day is provided. And with this graphical visualization, then the translator and the customer, they can come together in the frame of systematically developing the interpretant in the semiotic process in the sense of a dynamic interpretant. So what then would result at the end of the day? We have several processes going on. The ontology then ends up in the center of these processes. The 6 steps of translation in materials modeling, they may become a cycle, because the result, which is found by the modeling in this case, then provides new data, which can be used for the next loop. And the holistic approach for the work of the translator in cooperation with a project manager is facilitated by the ontology whenever the ontology is able to comprise the manufacturer as an organization and the end user with respect to the processes from a holistic view, which are related to the end user. And that is a possibility which is offered by the recent developments in MO. With this, I want to conclude and thank you a lot for your attention.
Thank you very much, Michel, for this, very, very, impressive presentation. Where I was in particular interested in a sense also by the, the benefits that you pointed out. That as you said, it's not the number 42, but you capture knowledge, right? And not just the individual solution. And that is obviously a benefit of using this process. But there's also, I mean, how do you see from your experience so far in the project and also with your experience in general of doing translation, we are introducing in the work that I guess you have been doing for many years, an additional step, right? I mean, okay, so we're saying, you don't get just the solution, you get a knowledge system, you get a common, you support the dialogue by this conceptualization. I mean, you listed a number of benefits in a way, but at the same time, there's a cost, right? Because, you need to bring in what you call the onto translator, or what we call maybe the industry commons translator. You need to also have the ontologist. You need, and we have had the experience. So how do you see that industry or your clients can be persuaded to make that investment?
In the end, I would say up to now, all of the knowledge, if we think in the frame of a project, is for one of the organizations, let's say the one of the translator, is in the brain of the translator, who's a person and can disappear or can become sick, can have holidays. And possibly it is written in a sort of several documents. So what is the experience is you may have some Excel sheets, you may have some PowerPoint transparencies, and it's distributed. So I think Peter called it something like a data lake, and it's not possibly only an industrial one, but that holds true, I think, as well for research institutions. So the effort must be done. And what I think is what may give a little bit of fear or slowly approaching the things to the people who will have to do it is that they do not know what at the end of the day will come up. So if they form a new system, which is built on a fundament, which is only for 5 years, nobody would invest. So if we have got something which persists and we have shown with demonstrators that it works, then I think people will join because they need to invest. I'm personally something like 55 years old, so I can think in 10 years, probably my employer, that's what I think, knocks at my door and asks, don't you want to come back and provide something of your experience? In the end, that's good for me. On the other hand side, for the employer, why shouldn't the employer use an ontologized knowledge? So for the employer, it's a good deal, I think. And also for the customers. And still, when I do not have to remember everything, then I can work with people together towards the future. That's what I still can do when I'm retired.
And what do you think, what do you see as the training requirements to become such a translator?
In the end, the way it's done up to now without the ontologization step, that is that a certain domain expertise is required for several domains. It's also knowledge basically of the language and then of the technical background of the innovation challenge. As it's basically lined out in the 6 steps, the understanding of the business case, and the business case in the end of the day, it always develops further. So I think presently what is clearly required and what I do not have as much is I do not know what the user of a product does. And I think this is something which needs to be captured, something like customers' behavior, or in this case, consumers' behavior.
I mean, just to say, I mean, what I see is like we have at the moment, you know, this scheme where we could say, okay, we have a you know, the subject matter expert, like let's say the industry client, they know all their products and so on. Then we have people, you know, like at Fraunhofer, other institutes like yourself and so on, that work with them. And now we bring in the ontology, and we have the ontology experts, right? So we have like a someone who knows all the detail about the specific things, and then the let's say the conceptualizer, yeah. So you do not need to know anything about how an ontology works, but you support the conceptualizing. You know what the ISO standards are, maybe the terminologies and so on. And then the person that is really you know, the data ontology expert. This is one way of doing it, yeah. But at the same time, each one needs to know enough about the other one, and yeah, so so I'm looking at the interface, let's say, between you and the person who is really can write the ontology in OWL, DL, and everything like that. How much do you need to learn, or you think, you know, first of all, I mean, that's maybe, you know, that's a good way of doing it. One could also split it up in different ways, but that would be one suggestion, to split it up like that. And then how much do you need to know about, you know, how ontologies work and, you know, this type of thing?
I think the amount I need to know is something, if I later on have a contact then to an industry client, I must be able to inform the industry client what is going on there. It must be transparent for him. And if I then talked to a specialist who knows about this interface towards me, and interfaces in adhesion research, that is basically the daily work, then as an adhesive, I just need to be able to work. I do not precisely need to know what is the adherent. So as a translator, if I'm asked good questions and I know what is meant by the ontologist, I can provide the information and the ontologist does the job. Or if it's not yet so far, I need to jump over and I need to do it myself in order to explain, we have to develop this interface now. But if it runs, I'm just asked the questions and I can give the information because I understand the language of the ontologist. So the requirement is I must understand what he wants to do with me, with the customer in the end. And I think this interface, to have it in a modular way, that's very important, because somehow the user-friendliness of the tools, which would be used to put some words into some machine, that is something which takes a lot of time. And if it works within 1 hour, everybody might say, I take the 1 hour. But if you need 2 weeks to fill the system, I think it would be a huge barrier to jump over. And if you have got a specialist who then says, okay, in 2 weeks, I come back to you with a result, perfect.
Thank you. We'll get back to that point, hopefully also after the next presentation, which will go, from what I can see, a bit more into the, well, as it says, the knowledge engineering translation into the ontology work, with the experiences from the biomedical domain. So I'd like to ask Nico to join the stage. Oh, here. Hi, great. Yeah, so to introduce our next speaker, he is an independent consultant for semantic technologies. specialized in biomedical ontologies and ontology mapping, with a PhD in automated ontology reasoning from the University of Manchester, and postdocs in ontology engineering and medical information systems. He's been working as a senior semantic web developer at the European Bioinformatics Institute, and since summer 2020, Nico's been working as an independent consultant on projects involving biomedical knowledge graphs, OBO ontologies, and ontology mapping. So we're very much looking forward to your talk. Over to you, Nico.
Thank you very much, Gerhard, for the introduction. Yeah, so just to give a little bit of a picture of what kinds of applications I'm concerned with. I'm very far or outside of the domains that most of you are probably in, like manufacturing. So I'm in the domain of genetic and phenotypic data. And what we do is we use ontologies such as the human phenotype ontology or the Mondo disease ontology or other ontologies to integrate data from a variety of external resources, establish collaborative workflows, integrate everything in knowledge graphs, and also build applications then that aid in clinical diagnostic processes. So for us, one of the biggest challenges in our area is the variety and the diversity of knowledge engineering stacks. So what I mean by stack is basically a set of standards, ontologies, and systems that are somehow interrelated. So for example, you could have the stack that is most familiar to many of you probably is the OWL stack, which where you have the OWL specification and related standards, ontologies built in OWL, knowledge graphs that make use of such ontologies, then various database systems that can be used within a stack. So for example, if you are in the RDF world, you would use triple stores and similar, and then tools, APIs, and libraries that build on these databases. And the problem is that generally these kinds of stacks are very diverse. So this is just an example from our sphere, so from the OBO, Open Biological and Biomedical Ontology sphere. This could look even worse in your own domain, but so this is really just as an example from ours. So you see some of the more known products, so it doesn't really matter whether you understand all the different technologies here. The point is just that they're different. So you see products like Protege here, which is used for manual knowledge acquisition processes. Robot, which is a command line tool we are using for lots of ontology processing. DOSDP templates, the OWL standard in one section. Then we have another stack, which is the OBO stack, which comes with other formats like the OBO format, other tools like OBO Edit, and the OBO Foundry in general comes also with its own sort of metadata standards like OMO, which codifies what kind of properties we are using across OBO ontologies, which are not always the same as other standardization efforts like across semantic web. And then the other stacks like the more semantic web stack with Sparkle, Shackle, Shex, and so on. And the labeled property graph stack with Neo4j, Cypher, and related ones, which is getting more traction in the recent years. And these are actually just a fraction of all the stacks that are used across our domain. There are others based on common logic, on Prolog, first order logic, some rule-based systems, and so on. So it's a very wide variety of stacks. Now, if you're on Twitter and you follow some of the big discussions around for and against various knowledge engineering stacks, let's say, you will see opinions such as, we absolutely need OWL reasoning to build our ontologies. And then again, others that would say, why you probably do not need OWL, or others that go even as far as saying, OWL proponents are motivated by wanting to keep their guru status. And then others saying, GraphQL will rewrite the entire semantic web. So all of these opinions, what these opinions all have in common is they are all made by some of our biggest experts in the wider knowledge engineering domain, and they all kind of stem from the frustration of being on projects where you constantly and continuously misapply various knowledge engineering stacks to business problems. And as was also mentioned before in some of the talks, knowledge engineering comes with huge, steep upfront investments. So some use cases require manual curation. If you're building a very high, an ontology, for example, that requires on lots of logical rigor, this is as expensive as it gets. Then we have a very keen lack of expertise, especially in our domain. We don't have enough people with solid software and knowledge engineering skills. And we have not enough people with knowledge engineering skills, period. But this leads to having a lot of application code that is built by either systems that are very badly designed and on the one side, or systems that make wrong assumptions about what is in the ontology on the other. And then there are very few opportunities for continuous professional development, and we will get back to that a little bit later. So generally, it takes a long time and a lot of time to building a knowledge engineering culture within any organization, and also in ours. Which is also due to the fact that there is a distinct lack of end-to-end tooling. So when you're in machine learning, you can open your Jupyter notebook and do everything from code cleaning, from data cleaning to inference and everything in kind of like one nice framework. There's no such thing in our domain. So this is really hard to get into it. The tools are very scattered. There are many technical stakeholders also that need to be brought on board, which do not understand knowledge engineering, and it's really tough to train them to understand a bit more about them. And so you really need someone to ensure that you're applying the right knowledge engineering approach to the right business problem. So what is this knowledge engineering translator here doing for us? They basically know which is the right knowledge engineering stack for which exact business problem that we are trying to solve. So this is a bit more speculative again here, from based on our experience with such knowledge engineering translation problems. So the first characteristic that we find that is really important for someone that is doing such a job is their own awareness of internal technology biases. So you hear very often in these meetings about technology, if it's not RDF, it's not fair, or if it's not OWL and sound complete and terminating, it's not an ontology. But I may love OWL, but maybe it's not exactly the right tool for the right job at the right time. Then, which is obviously what you're all about, the translator has to be keenly aware of business problems. So for us, the main purpose of our product is to enable users to find the genetic basis of phenotypes. And in our experience, we have built a lot of huge ontology efforts and semantic solutions that did not actually address the key value propositions of our business problems. And this is really something that can waste a lot of money for any organization. Then a keen awareness of the semantic trade-offs. This is a picture that that my mentor in postgraduate years, Bijan Parsia, was using. And this is a slightly simplified form. So when you are choosing a knowledge engineering stack or formalism or something, you always have to choose between various trade-offs. So expressivity means here, what can I say? What kind of knowledge can I express? Cognitive complexity, how hard is it for a human agent to actually model with that formalism? And computational complexity, how difficult is it to reason with this kind of formalism? So we have many frustrated people from industry, from research coming to us and saying, oh, I'm trying to reuse this ontology, and but if I try to run the reasoner, it takes 3 hours and nothing happens. So these kinds of problems with computational complexity. And we have to be aware, if computational complexity and cognitive complexity go up, costs for our organization goes up as well. And then we should be aware of the various mitigation strategies for these trade-offs. In particular, we know things like we can use design patterns in combination with templating system for building our ontologies to reduce the impact of cognitive complexity by reducing also the cost of knowledge acquisition for building our ontology. So this is one important thing. How do we build bridges between the different stacks? For example, we would be aware that there is a that there's a plugin for Neo4j that allows us to export and import RDF into Neo4j. And we are generally very aware of the landscape of various tools, their maturity levels and cost, because as I said, they are extremely scattered. So one thing that we would know, for example, is we should not build an OWL API-based system, which is very hard to maintain, if all we need from the ontology for our downstream system is labels, synonyms, and subclass relationships. And lastly, we should be aware of the principles of fair semantics, reuse, and collaborative workflows, such as the ones that are promoted by the various organizations we've heard about this morning, and the OBO Foundry, like where I am involved in, and the and many other foundries that exist out there. And we have ideas about how can I reuse Cabby, for example, to build my materials ontology rather than starting again to build from scratch a new ontology from zero. We should be familiar with, but not necessarily an expert in, knowledge representation formalisms like OWL and their semantics, various reasoning approaches, implementations, and the ideas behind neurosymbolic and AI and how it relates to knowledge engineering. This is my last slide. Some suggestions on cultivating knowledge engineering translators. So in our experience, knowledge engineering translator cannot really be hired or contracted very well. They need to be cultivated, especially since their primary goal is to be very aware of the business cases, which means they need to be intimately familiar with the value propositions and business goals of the organization. So one thing that we suggest, for example, is to consider, instead of hiring contractors to do your work, to actually hiring experts, teachers to build up continuous professional development processes in your organization. So one example for this is when we were hired, a group of us, to build for one company an internal course that to teach some of the employees of this company. And the premises and the idea was to build a course that is purely based on self-teaching materials so that they could reuse and reuse it further even after the course was over and continue to develop it. And indeed, we were also donated this course to publish it, and were able to also continue to developing it. And we're still doing that, and to teach other groups of people in these technologies that are relevant to our domain. Then this is what you're doing here, inviting speakers from OBO Foundry, NCATS Translator, and other related projects to ask them about failures and failed experiences and successes. Academic gifts as a tool that can get you closer as an organization to academic institutes, and provide your own knowledge engineering translators to learn about different technologies. And generally, lastly, invest in open ontologies, open source, and open data, which opens the door to, first of all, a lot of talent and expertise that you could use in your organization, but also aids the sustainability of existing resources. That's it. Thank you very much.
Thank you so much. This is you've done a lot of work, if we may use some of that and quote you for our roadmap. So this will be very, very useful. Can I just, for understanding and of acronyms, can you just say what an NCATS translator is?
So NCATS is a project that I'm not involved in, but they are working a lot in the area. So I realize that the word translator is used in a lot of different ways, and here we are talking about translation also in biodomain and environmental stuff, but I'm not directly involved in them. But I know that there's a lot of great people that know about translating between the domains and knowledge graphs and semantic technologies in this project.
Thank you for that, and for that clarification. And I would like to also ask you about this training, which is really a fantastic idea and initiative in that direction. What is the type of background required, in terms of knowledge in knowledge engineering? Sorry, what I mean. Who are the people that you can train up in this way?
So for this company, for example, they had data scientists and data curators that the company wanted to become more like knowledge engineering translators, so people that would promote the use of semantic technologies and understand where to apply them. And so they asked, they specifically wanted to train these people up to and make them more sensitive towards these different knowledge engineering and semantic technologies out there. So for these are there, but generally, I think when we are talking about a knowledge engineering culture, we should think that many different groups of people need to be trained and sensitized towards towards knowledge engineering, and these range from curators to software developers to data engineers and data scientists, because all of them are impacted by the technology stacks, and all of them can make use of them, draw value from them, but also can be quite hampered by the use of technology, especially data engineers, which always complain that their data pipelines become so much slower now that they have to incorporate things like reasoning and stuff like that into their pipeline. So I think that all of these need to be trained in the basics for these technologies.
What is your view on, what I also asked the last speaker in terms of, this translation, as we've heard it today, we deliberately, here took quite a wide approach, right? I mean, starting with examples and materials modeling, but also, really starting with industry problems and translation kind of outside of the knowledge engineering, and then going into the knowledge engineering, which, is a team effort. It requires many different people with different skills. I mean, how do you, obviously what you're saying, if I understand you correctly, it's important that along that chain, people are trained at least to various levels in what knowledge engineering is. Is that's correct? And how would you sort of divide up, this chain of events, as it were, in terms of the roles, right? I mean, there is as I said, there is the person in industry who wants a problem solved, right? There is maybe another translation expert who generally works with industry to provide types of solutions, like Fraunhofer and so on, these types of institutes and so on. There are, all of that's happening before we even get to knowledge engineering and so on. So how do you do that?
So this is a really great question, and one that is that I'm very, very interested in also generally developing further. But the first answer, very crudely, is what you, as I've seen now in some of the previous talks and also some of the materials you've generated, you're already doing very well. The first is to really clearly define the various roles, groups of people that interact in one way or another with semantic technology. So that's what I would say is the first step. And what we did, for example, for this course, is then we kind of try to create a hierarchical model of our continuous professional development process, where you have like common lessons that are kind of that everyone from every different role would be familiarized with, and then going to ever more detailed steps, like how do you build ontology pipelines with make and automation and continuous integration processes, which are more focused on data engineers and software engineers. And basically what I would try first is getting clear what kind of roles are interacting with you. We have listed a few roles in this material there that you can see for our domain, and then see what is it that they need to understand about the technology that then semantic technologies. And the last thing I want to mention here is actually what is really a good idea is to teach them a little bit more than they need to understand, because we have had great successes actually to have like classical database curators trained up in ontology workflows, in reasoning, and even templating systems, stuff like that, that they and querying, that they can now generate value that they didn't know before, and they fixed it and they went over to applying these things by themselves. So I think that's kind of like how I would start.
Yeah, that's I think a great point. It also reminds me of another presentation which we had in Ontology Commons from someone who works for Siemens, Biomedical Domain, who kind of that remark stuck in my mind about reasoning and so on, and conceptualization for reasoning. The experience that when they worked with the kind of engineers and so on, they often discovered that once they built the ontology, they wanted more reasoning than when they started, because they didn't really understand what all the things that they could do. And once they realized that, then they, so this type of gap, I guess, in knowledge would have helped in their case as well. The other thing I found from the work we've done so far is that, and again, just to get your reaction, is that people often, that there is a key step in the conceptualization in terms of vocabularies and definitions of things, and so there is actually quite a lot we can connect to, because as Michael pointed out, there are a lot of ISO standards with definitions. What is a product? What is a service, and so on. And if we use that, and we can connect with people on a certain level, which they are kind of quite comfortable with. So that seems also quite a good way for the translator approach. Anyway, I'll leave you to comment on any of that if you like, or you're nodding, but also I'd like to invite Michael and Peter back to, also put your cameras on if you like, or if you have any questions for each other, please go ahead. And while you're doing that, I wanted just to read out one question which we have here on the Q&A by Emna Amdouni, saying, are there some initiatives to translate Obo Foundry principles to FAIR principles? And are there any references?
So I think this what we need to understand first of all is like that what we call FAIR principles probably is not as clearly defined in a centralized place as some of us may want to think. So for us, Obo Foundry principles are very much FAIR principles as well, and there are efforts like FAIR is Fair, which I would recommend for you. Like there is this effort called inside of FAIR is Fair, which is called FAIR Semantics, which is doing a lot in trying to fairifying semantic artifacts. Or they also have a GitHub present and some various websites associated with it. But for the Obo Foundry side of things, I do personally consider Obo Foundry principles already as contributing to FAIR, and but to very clearly answer your question, so there's no effort right now to put Obo Foundry principles directly in a centralized repo of FAIR principles that can then be, that we would reference to as inside of your domain. So that probably there's no such effort, no.
Thank you. So Peter, Michel, do you have any questions, comments? Please go ahead. If you do so.
Yeah, please. If Nico would like to answer. So I think, Nico, I liked a lot your hypothesis or statement that the right KE approach for the right business problem might need to be chosen. And as Gerhard discussed before with me, what is the time expense in implementing a system? Then it's basically the same. If you implement a quality management system, it takes a lot of time, but afterwards you profit. And the question then is, do the costs pay back? Well, you would need to know what is the very huge business thing. On the other hand side, in manufacturing, I would say if I have to tighten a screw, I do not program a robot, I try to do it myself. So what is the typical time scale of a business problem that you strongly profit from using this KE approach? I think it's not 5 minutes tightening the screw, it's possibly 5 months, 5 years.
Yep, that's absolutely right. So if you are betting on, for example, we know that building OWL ontologies, especially in the more higher profiles like OWL-DL, beyond EL, beyond RL, so more expressive logics, if you build an ontology in this realm, it will take in a large scale, it will take years to get it to a point that the entire community will be able to use it. And the problem is that the real benefits of that ontology that's especially true for us. If you have an ontology that covers a third of the diseases, that is not going to help us much. We need something that covers all of them, or it doesn't give us anything. So if you have this huge upfront thing that you first need to build the whole ontology before it gives even a little bit of value, then you are talking about years in terms of how long this takes. But the other side is that you do not always need to build an OWL ontologies with like beautiful DL axioms in it. Sometimes a taxonomy that you completely auto-generate using an inductive approach, where you take some databases and let some machine learning approach automatically build you an ontology. Sometimes that's enough for your use case, and that you can deliver such a thing in much less time, like even weeks to deliver value to you. You just need to know, is this rigorous enough for your particular use case?
Probably a question on my side to Nico as well. How do you see in such a, I think, more strategic framework as you described, how do you see the role of materials modeling in such a setup? I mean, materials modeling, okay, we have, of course, simulation which run sometimes even for weeks, if you like. Yeah. So how do you see the rule of such a more short-term thing like materials modeling in a framework like the one you described?
I'm sorry, I would not be able to answer that now without a bit of blah blah. So I would rather not say anything about this, because it's a very good question and I don't want to pollute it with some half-assed answer. So I don't know exactly. Sorry.
But an analogy is probably that you explore a few diseases and then you want to integrate it into your, I don't know, into your system. What's the effort in this case? And
so let's say,
I mean, you told us you need everything or you have nothing, yeah, in a sense. But I mean, new diseases show up, and as you have seen in the pandemic in the last few years. So how do you cope with this system?
Yeah, I mean, that's exactly what the knowledge and engineering translator needs to see. Like, if there are use cases where, for example, let's say in the COVID pandemic, we hacked together, I'm saying, but we really built also solid things in the course of weeks, like knowledge graphs that integrate data that is relevant to COVID in very short periods of time. So, and which required obviously lots of collaboration and kind of people talking to each other and contributing to each other, but it was possible. But here we are talking about like one disease, and the use case was integrating all the existing data, and we had like a relatively small domain model. But the size of the domain model depends obviously on the use case that you need to solve. So if the use case demands only a relatively small domain model, I think you can deliver it more quickly, the solution.
So what you're telling us is that everything depends on the scoping, if you like.
Yeah, exactly. Yeah, definitely it does. Yes. The scoping and the required logical rigor. These are the two main components. So if the logical rigor requirement is extremely low, then you can even get away with highly scoped projects, because you can, for example, which many people do and it's super successful, to use tools like Wikidata and other ones where you already have big domain models that you can integrate into and reuse. So if the logic rigor requirements are lower, then the cost drops drastically and you can deliver value even for bigger domains.
I'll just do a little poll. There's also a question on Q&A. One on what is the role of translation in innovation development for all speakers?
Yeah, from the point of view of WIP code, I mean, I had it on my slides. So the idea is we need to enhance the rule of translation towards collaborative innovation development. And how to do that? I mean, we have a strategy to do that. It's not realized for now. It's to use collaborative gaming in order to bring the stakeholders together and to set up a kind of a innovation game, if you like, where part of the rules is that either everybody wins or nobody, using this kind of shared value approach. Not sure if this answers this question, but yeah.
Yeah. What do people think about knowledge engineering carpentries similar to the software carpentries? Any view on that from anyone?
So the this course that I mentioned before that we started developing for this company we were working with, one of the big premises is there is a huge amount of super useful teaching materials out there. And I think that actually there are a bunch of units in this course that we used to do that actually refer directly to software carpentry lessons as well. So I don't remember exactly because I wasn't involved in this part of the course, but I think that generally the idea behind software carpentry is exactly the right spirit for building up a knowledge, a continuous professional development culture, because the biggest mistake, in my opinion, for teaching is to organize tutorials and organize trainings and things like that, which involve some expert to come and teach a skill. So that's kind of like the thing that works very badly and doesn't really teach the skills to enough depth. While this approach that software carpentry and this other thing, which is flipped classroom, do is you go and learn you provide the self-study materials for the people that then get their own minds wrapped around it, and then give them an opportunity to reflect with the experts on their training experience. So I do think that something like knowledge engineering carpentry would be super useful for the wider community.
Oh. Yeah, very interesting. We've only got a few minutes left. I wanted to come to the point of recommended action. So for the roadmap, and obviously we already heard some in terms of the training requirements and so on. I mean, because obviously we, as a project also and as a community, have the opportunity to put this to policymakers for research funding, for other funding programs, initiatives, associations that could do things. So what would be, maybe from each of the speakers in the last few minutes, what would be the things that you would ask for if you could get a pot of money to spend? Let's go through the same order as we had the talk. So starting with Peter.
So from my point of view, I would like to see a project where this kind of open innovation approach is really put onto the next level, into the direction of more sustainability and deeper connection to policies like the Green Deal, to these overarching policies, and engagement from probably even from politicians in this project as well. We have seen in many places that there is still a deep gap between what science can do and what science can predict and what politicians make out of it. And it's probably time to bring these two actors more closely together. That's at least my point of view.
Thank you. And Michael?
I may have not an extremely clear total scope. In the end, when we did this kind of review paper with respect to translation in materials modeling, I think it became clear that most of the processes that are applied hold true as well for materials characterization. And I think this is, at least in manufacturing, always the link to the customer who works with a certain material and typically has an issue with the material in his hands. So I think the materials characterization would be a very good bridge. Then I started from the ISO 9000, so that's quality management. As then we also worked out the translation is also a process, so it is accessible for quality management. So quality assured translation is a good idea, and that means it's always rather easy to connect the training that Nico, for instance, lined out, but also Peter, with the target of getting a process which is important, quality assured and quality managed. And the question why the process is important, somehow I would say that is something what one could figure out. In Germany presently, there's the formation of a new government. So some of the political topics that were just discussed at the end now, they are in the focus of everybody. And there was, for instance, one SME presented in the TV who can calculate how much is the contribution of an email sent to the CO2 footprint. And I think this is something, if we say we have got a huge target, and starting from the target, we must ask, what can we do to contribute to reach lowering of the heating of the Earth? Then it becomes automatically clear what are the bricks which in the end need to be moved. We cannot have isolated domains, and the business model which is behind all of that cannot be remaining in a way that I sell a product in competition with somebody who also wants to sell the product, and the one who makes more profit wins this competition. And that's why I basically, when I think about gaming, I want to win, obviously, but somehow in this case, everybody should win. And I think that's a game where everybody wins. That's perfect. And that is very good for the next 20 years. And so the ontology and also the translation, they might say, that's my typical procedure is I want to know how can I help my customer? But in the end, if I start now being trained, I have to ask before, how do I want to help my nephew, for instance, to have a brighter future? Then I do the translation with a certain idea behind. And the ontology helps to put this high-level idea to which everybody would agree, like the Sustainable Development Goals some 30 years ago. Everybody agrees what is the target we want to reach. Then we see that the investments can easily be made. And then the question is only how can we do it? It's a technical question. And I think this is, for me, this huge business challenge. If that can be formulated, then we see how much money is in the market. And I think that's billions. That's much more than we can do in our working lifetime. But we must invest it. And I think the tools that we provide, I would like to have a good tool for everybody, possibly not with a mobile phone, because they also cost some CO2 footprint, but somehow a tool which is intuitively operable for everybody and shows what is the effect of an action, so everybody can control himself.
Thank you. We are running out of time. I just wanted to mention what Michel Magas put there to Peter, but I think it also applies to what you say. How do you feel about mission-oriented collaborative innovation in comparison to gaming? But we will not be able to discuss that question more. I think this is the sort of topic we're talking about. Just want to give also Nico the opportunity to say something on spending that pot of money on certain actions.
So for me, the key and most important thing to put in front of policymakers is the open part of fair and open ontologies. So we have done a lot of work recently to sensitize especially various industry branches like pharmacy for the value of fair, but we have done not enough to convince people of the value of open, which means actually making it publicly available and reusable for other people. And in my experience, working with many different ontology stacks, ontologies are chronically underfunded and super useful. So I personally would say fund organizations like Obo Foundry, the IOAO, which we heard this morning, the Industrial Ontologies Foundry, and so on, and make sure that these are the most suitable groups to actually also put together trainings, tutorials, and things that are useful for the wider community to use. So that's what I would say, where I would go and try to convince the policymakers of.
Thank you very much. Thank you for that, and thank you to all our speakers again, and to the audience for your participation and questions, and of course Ontology Commons will keep on going. We will, in fact, in this particular area of translation, we are going to have as kind of a standalone small workshop for a day, again online, where we are going to get together and discuss this more in terms of these aspects of the role and so on. And it would be great to have you all back for that sometime next year. So thank you very much, and we'll, I guess, go into the lounge now for break and for the lunch break, and which you can either enjoy on your own or at a table in the lounge. Thank you.
Thank you, Gerhard.
Thanks.
Bye.
Bye bye.
Thank you all.
Thanks a lot.
Bye.
Bye.
Bye bye.